what happens here is that we get, Whiskey, can you signature an old, please? Thank you. What we're going to look at throughout this entire chapter are these things called points of concurrency. Points of concurrency are where multiple segments meet within a triangle. We're going to not really this one, but we'll have them for angle bisectors, medians, altitudes, all these different little formula stuff that we're going to set up and work with, as well as what are called mid segments. Traditionally, this has been a rather quick chapter. I know that we're going to start the first section today. I think there's only 6 total sections in it, which means after we get back from break, we'll be done with it, I don't know, that middle of the following week, so whatever, the first week of December, which is fine. And that gives us plenty of time to kind of finish out and get into the 6. Now, as far as finals and stuff are concerned, I know that finals are after break, but I don't, it's so stupid, I agree. I did. I don't know, I don't think we can change that. I don't think there's anything you can do about that. Those are the people down at the education center that makes those decisions, people that deal with calendars, that don't have anything to do with people at the high school. I know. If it's something that you don't like, obviously most high schoolers don't, go to a board meeting, fill out an index card and say, why don't we have finals before break?
And if they say it's too hard to configure, say, then talk to Sycamore School District because they figured it out.
Now when you start to get down to it, if you start thinking about literally how many days you have, our break this year is really weird. No, it's the same amount. It's just we're out with our last day is the 21st, so we're here on the 21st, and then we come back on the 4th.
2 days after my birthday.
So what happens here is that we could have finals then don't go until 11. So if you look at it, if you come back on the 4th, you've got 1, 2, 3, 4, 5 days, and then finals start. So what's the point of that? You can't finish anything. You can't start anything. It's just a waste of time. Now, so you think about it, then you have to be able to move up your schedule. 9 days, basically. So you go back and you think about all the extra days when we started. We didn't start school to the 31st or something? Why couldn't we start it the 22nd? We started on the 24th? Okay. So why don't we start, because then why don't we have our institute days to 18, 19? School starts on a Monday. You come all the way through. Then you go through September. September was fine, you just had Labor Day. But then in October, we have the institute here and here. They don't. There's another day in here. We have all those extra days off in November.
So Sycamore has
Their conference. Now, the other thing that is kind of weird about their conferences, though, their conferences are so much later, which is kind of defeats the purpose a little bit for high school.
But they don't do conferences in the spring.
Right.
Because think about how many parents come to conferences in, is it March or April that we have them?
April. I book solid all the time.
Really?
Math department's always booked solid. We're always booked. I know, but we're the only department, if you look at the list, that works out. So anyway, let's talk about what's called a mid-segment. This is, what do you think, this is a real tough thing. Let's think about words here. Mid-segment. Gee, what do you think this is? Segment in the middle. Gee, where do you think the segment in the middle is from?
Midpoints.
From midpoints. Guys, mid-segment is just a segment that connects midpoints.
So is that the same as a segment?
Segment? Mid-segment. Oh, did I spell it wrong?
Yeah, I thought that was.
Or actually, it would change.
Hey, I don't know what you're talking about. Thanks. It's how much you pay attention. That makes me feel good.
Mid-segment.
So, mid-segment. A mid-segment in a triangle connects midpoints. So, midpoint, remember, a midpoint cuts a segment in two congruent parts. Now, what we're looking at here is that that segment connects those two parts, and it's parallel to the side it doesn't touch. So a mid-segment does two things. Connects midpoints and parallel to side there's your mid-segment. Mid-segment connects midpoints, and it's parallel to the side it doesn't touch. How many mid-segments can you have in a triangle? How many sides are in a triangle?
3.
You could have 3 mid-segments. Okay. So you could have 3 mid-segments in a triangle. Okay. That's how it works itself out. Oh, sure. I got one. Excuse me. Caleb, catch.
Oh,
I was gonna say,
I
what's
do
it
know
called?
better.
M-Y-N-A-M-E.
Which one's Murphy? Mr. Murphy. We'll call you that.
Sorry.
Keller.
Oh, I did? Oh, sorry. Anyway, so mid-segments, you can have 3 of them. All right. You're right. It makes it a little bit smaller triangle within the triangle. We'll talk about what that means later. Also, one other thing of the mid-segment, actually this is too long of a winded thing. In the mid-segment, is equal to half the side it does not touch.
Wow.
It is parallel, it connects midpoints, and it is equal to half the side it doesn't touch. So basically what's going to happen here is that you're going to be given a mid-segment or you're going to be given a side across from it. And you're working back and forth. Okay?
Wait,
So the mid-segment is connects midpoints, parallel to the side it doesn't touch, and equal to half the length of the side it doesn't touch. Julianne Fries.
Oh, and four pieces.
Good night, Irene.
That's the one.
We try. So this is quite literally how easy this stuff winds up being. You're going to be given a triangle. It tells you that segments S, T, and TU are mid-segments. If they are mid-segments, we'll be able to use those values to figure out the different parts of the triangle. So, excuse me. So when you draw this out, so we have like 2, S, T, U, T, 8. Oops. Now, we know that happens because it says so. Oh, ST and TU are mid-segments, which means they have to connect all the midpoints. So what I would do in my diagram right away is put in my tick marks. By putting in my tick marks, then I know what everything is going to work out to be. So I'm given QP is 10, which means each smaller segment is how much? 5. That's pretty easy. Isn't that half of 10? What other segment, turn it off please, what other segment is equal to 5? To you. Because this is the mid segment and it doesn't touch that side. 8 is the mid segment, which means it doesn't touch this side, so how much is PR? 16. Which makes each individual part 8 and 8. What happens here with these mid segments, you get a bunch of congruent triangles. Yes, ma'am. If this is half of the side it doesn't touch, I just double it. Because 8 is half of what? 16. Okay.
Wait. So it's half the little triangle? Half of the side, I'm also talking about the little triangle?
Which one? This little guy here?
No, it's like the line above it.
Okay.
Yeah.
So this is the mid segment. Okay, it's connecting midpoints. This value is equal to half the side it doesn't touch. It doesn't touch that side. 8 is half of what? Okay. Now, what happens here is when you have your triangle, you've got your midpoints.
Beautiful triangle.
Thanks, bud. Appreciate it. What happens here is that you've got your mid-segments. All I've plotted on my diagram are the midpoints. Are you okay with that? Now, I want you to think of this in terms of a generic algebra problem. If I call each of these, this segment here, x and x, does that make sense? Because is x congruent to x? Yes. Now, that makes that whole side how much? 2x, very good. So that makes this whole side 2x. Are we okay with that? Now, that also means that this is the mid-segment of it because it's connecting midpoints and it doesn't touch this side. This whole side is 2x. Agreed? What's half of 2x? Which means this is, notice, it's congruent to those two. You do the same thing. If I call this side here, we'll call this one y and y, which means this whole thing is how much? Which makes this much how much? Very good. How many tick marks does it get? 3. Make this one a z and a z, makes the whole thing how much? Which makes this. Oh.
What?
I know, it looks a lot more complicated than it really is, because what happens now is you get 1, 2, 3, 4 congruent triangles out of that. Yeah. Look at your tick marks. Side, 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 side.
Side.
What's that? It's witchcraft, yes. Okay? I just wanted to show you that's what's going to happen here. It is, you get, excuse me, if you know what the value is for the small segments on the outside, you know what the values are for the triangle on the inside. That's how it is. That's how it works. Okay? Not terrible? All right, let me show you some algebra then.
My favorite thing.
Liar.
Ooh. Who's a liar?
Ah, here we go. I'm just going to go right to this. Go right to the algebra. In the diagram, let me draw this up a little bit bigger for you guys. In the diagram, x
Beautiful picture.
is y is z. So we have this pseudo diagram where these are mid-segments.
We're missing one line.
What's that? Was
You're missing the line that connects you to
Thank you.
Is that a V? I'm guessing.
Yes.
Okay.
I was just trying to draw that picture a little bit larger.
Is it ever just gonna give you like the two sides of the little triangle?
Yeah, it might. You just might be working with those two sides then, and you might not have to worry about that third part. Because there's examples where, and I kind of skipped over where, markers over here. Those would be examples that look like that. What's X? There we go. I don't think I needed to worry about that problem, did I?
Yeah. So,
It connects the midpoints.
oh, I wasn't talking about that. I was talking
Okay. Now, when we get to a problem like this, it is really important that you understand how you set it up. Bless you. Bless you. So they're saying that UW is 4x minus 1, and YZ is 5x plus 4. Now, which of those two is the mid-segment? The UW. So the mid-segment, remember, the mid-segment equals half, move this over just, oops. The mid-segment is equal to the half side not touched. Okay? If I think about it in terms of that, what do I know is equal to the mid-segment? What value? Bless you.
I think you're -1.
4x minus 1. So I can write 4x minus 1 equals half of 5x plus 4. Now, there's two ways to write this out. Bless you. We know the mid-segment is equal to half the side it doesn't touch. Or I could double my mid-segment, and it equals the side it doesn't touch. Remember, I should have a marker over here. So if the mid-segment is half side not touched,
Oh, so it's basically.
how do you undo multiplying by a half? You multiply it by 2 to bring it to the other side. So there's two ways of writing this. Double your mid-segment, it equals the side not touched. That's the two ways to write that out.
So wait, you can say 8x minus 2 equals 5x plus 4.
Perfect. Oh, I'm sorry. Yeah, exactly. Because there's two ways of writing it out. Okay? Whenever you're dealing with the mid-segment stuff, you have the mid-segment and the side not touched. The mid-segment is half the side it doesn't touch. Or if you double the mid-segment, it equals the side it doesn't touch. X is half of 16, right? What's half of 16? 8. If I double 8, what do I get? Works both ways. That's just writing it out algebraically. That's it. So there's two ways I want you guys to remember when you're worrying about the definitions of mid-segments. It equals half the side not touched, or you double it, it equals the side not touched. These two are the exact same setup. It's just sometimes one is easier to use than the other. Okay? That's it. That's it. We're gonna deal a lot in this unit with this moving a fraction to either side. It happens quite often. Okay. So let's finish this out. Whiskey, you just said that I can rewrite this as I double 4x minus 1, and it'll equal 5x plus 4. All I did there was I multiplied both sides by 2. Here's where you're gonna screw up. Here's why I don't want you to screw up. Distribute to both terms. Half of you will forget to send it to the negative one. Perfect. Please do that. Always draw those little arrows. 8x minus 2, 5x plus 4. Variables on both sides of the equation, who do you pick on? Little guy. Move the 5x, move the 2. Move this up here. We get 3x is 6, x is 2. And then I think it asks us to find a specific side. UV. Okay. UW then would be, well, if I substitute in 2, I have 4 times 2 minus 1, and it is? 7. There you go. And it's also not a bad idea to check and make sure that if that mid-segment is 7, what should the big segment equal? All right, well, what's 2 times 5? Plus 4? Yay, we math. Yay. Thank you. Thank you. Are those your guys' warm-ups? It's a nice jacket. It's very nice. It's very nice. It's not terrible, is it?
It's just you gotta like.
You have to,
Cut.
and that's the thing, you just have to slow down. Really, it quite breaks down just slowing down and looking at your diagram. Yeah.
Or sometimes they can be like, so you like have to make sure you're right.
No, because if they're saying, if it tells you it's a mid-segment, you follow it. Okay. There is, yeah, because it's not gonna set you up to fail. Because they're not
I
gonna,
don't know, they'll do 2,000.
oh, I see what you're saying.
Or like the.
It might ask you, is it a mid-segment? You know what I mean? But then you'd have to have numericals to make that work. You'd have to have numbers to make it work. Whereas if it didn't, if it said 7, oh, I think I know what you're talking about. So if you have something like this. Can I assume that this is a mid-segment?
Yeah, that's right.
No.
So it's the other, so it's 1, 2.
Is there midpoint, are there congruent tick marks on that bottom segment?
Is there have to be?
There would have to be. Because here it's not saying that it's connecting to a midpoint. It's not saying that it's doing that. It could even have something like this. Was that technically a,
No.
right, because it's not an actual midpoint. Is that kind of what you're getting at?
Yeah.
That's exactly what it could look like. I don't think that I've ever seen that, but that's a great question. That's a really, really good question. All right. I love the fact you're looking forward to like the worst case scenario.
Yeah.
That just makes me happy. Yeah, right?
Yeah.
Where's the other one? I want to try a couple more of these out.
Did you figure out all of them, like, how we're supposed to give us like the
I will show. It depends on the question. All right, let's take a second. Let's take a second, and I want you guys to use this information with that basic diagram and answer it. I just want to focus on the algebra of this, because I think that's probably where we need to be for today. I don't know if we'll do any of that coordinate, John. You know, kind of like move it over 4 units in the left.
Yeah, we did that last year.
No, before they gave us.
Touche. All right, so let's see here. We had 8x minus 2 and 2x plus 1, 11.
I was about to say, I just did this one.
So that means we can do one of two things. We know that this one is equal to half the side it doesn't touch, or I double it and it equals the side it doesn't touch. Does it matter which way you set this up? No. This case, if you said half of this, it's all right because both numbers are even. You can take half of 8, you can take half of 2, that's fine. Or if you just go ahead and just double the mid-segment, it equals the side it doesn't touch. Remember, you need to distribute to both terms. Most of you will screw up because you'll forget to send it to the 11. Okay? So 4x, 22, 8x minus 2, which means I pick on the little guy. I'm going to move the 4x, at the same time I'm going to add 2. 8x minus 4x is 4x, and we get 24 is 4x, therefore x is good. Now, then I think it asked to figure out what J was, so let's see, 8 times 6 is 48. 48 minus 2 is 46. Now, if we check our work just to be on the safe side, 46 times, or 6 times,
Yeah, it should be
6,
plus 11.
yeah, for some reason I'm looking at that as a 1 again, like to space that out, I can see it better. So I get 23, 23, and 23 is, there you go. This is not that bad, is it?
Yeah. So does that mean, Mr. Murphy, that segment HE is 23?
Maybe,
And segment EJ is 23?
maybe. You want to do one more, or are we going to call it a day? One more. One more.
I was ready to call it a day, man.
God, help me get one more.
Yeah, same diagram.
Office doesn't make sense. No, it requires a lot of math. No, it actually requires a lot of mental thinking.
Yeah, it's the same. We use the same diagram. Same diagram. Sorry, just bringing it all back together. Bless you. Bless you. So I know that EF is the mid-segment. It's going to equal half the side it doesn't touch, or double the mid-segment and it equals the side it doesn't touch. So right off the bat, I'm going to write it as double 2x plus 7 equals 5x minus 1. Distribute out 4x and a 14 is 5x minus 1. X is 15. Very good. Add 1, subtract 4x, and then just substitute back in, because now you got to find EF, right? So what's double 15? What do you get? 30 and 7 is? Very good. So this is 37, which means the other side should be double 37. So we check it really quick. 5 times 15, well, that'd be what, 75? 75 subtract 1 is? 74. Hey, is half of 74?
No,
It's 37.
after 34 is 30.
There you go. Let me give you some props. Yeah.
Are you turning this in?
Yeah, I'll collect it tomorrow. Let's do this. I'll open up a tab and I'll show you guys where it's at. So this is section 5.1, page 298. We're going to do some, I'm going to show you guys constructions of all the different points of concurrency that we're going to be doing throughout this unit. Okay? Now remember, guys, I have a spot. This is bookwork here. When we did this the other day, let me open that up for us. So if we did this, remember, the geometry book, we're on chapter 5 now. I'll put it back in a second. Gee, where do you think we're going to click for the chapter 5 book? I don't know, maybe where it says, I don't know. It only goes chapters 1 and 2. So you wouldn't get very far because the PDF files would be too large. Well, for chapters 1 and 2 it worked out. And then just click on there. Okay.